This is section 1.7, inverse functions. In this video, we're going to go through an example that's really similar to number 43 in your book. It gives us this function and it asks us to find the inverse and to graph both the original function and the inverse function. Alright, so here's our original function and I already graphed it. Before we find the inverse function though, let's first talk about the domain and range of this function because that'll come in handy when we're graphing our next function. So my domain of this original function, I think, are there any x values that wouldn't work if I plug them in? Nope. I can plug in any x value I want, I'll get a valid answer. So my domain is from negative infinity to positive infinity. My range though, even just looking at the graph, I see that my range will never be less than positive 1. So my range goes from 1 to infinity. And this relates to our inverse function because remember, our inverse function, we just flip the domain and range. So for our inverse, our domain becomes what our range used to be. So our new domain is from 1 to positive infinity. And our range is what our domain used to be. So our range is from negative infinity to positive infinity. And let's go ahead and actually find our inverse function. So remember, to find my inverse function, I'm just going to flip my x's and y's. So instead of having y equals this, I'll have x equals y squared plus 1. And now, isolating y, I get that the square root of x minus 1 is equal to y, and this is my new inverse function. And to graph it, I'm just going to plug in some points. Now, I would plug in the same points that I plugged in for this graph, but I notice if I were to plug in negative 2 into my inverse function, I'd end up getting negative 3 under a square root, and that can't happen. And that makes sense because I already knew that my domain goes from 1 to positive infinity because any value less than 1 will give me a negative under the radical, and that can't happen. So I'll start with my smallest number for the domain, 1, and under the radical, I'll get 1 minus 1, or 0, which is just equal to 0. Then I can plug in 2, and I'll get radical 2 minus 1, or rad 1, which is 1. But remember that for radicals, I have both positive and negative values. So I could have positive 1, but I could also have negative 1. Both of these values, when squared, will get me back to positive 1. And I could try another value like 5, just to make our math easy. When I plug 5 in here, I'll end up getting rad 4. And remember, radical 4 is both positive 2 and negative 2. Alright, and if I were to go ahead and graph this, I have the point 1, 0, which is here. Then I have the point 2, 1, which is up here, and also 2, negative 1, which is down here. And then I have the point 5, which is somewhere over here, 2, and 5, negative 2. So my graph is going to look something like this. And that's it for this problem. So first we had to find our inverse function by flipping our x's and y's. Then we just had to graph both of the functions. Notice that our domain and range switched when we found the inverse, and we got this new function here. The concepts covered in this video are true no matter what pre-cal class you're in, but in case you're interested, all the problems referenced in this book came from this lovely book right here. Remember that if you're a Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either make an appointment or drop in whenever you're available to get tutoring in pre-cal, calculus, and a bunch of other subjects as well. Feel free to visit our website for more information.